firm, inbound, 30 starts on BTR. A firm, solid copy, 100 over 100.
Hey guys, and welcome back to DCS. Today we are sitting in the UH-1H Huey, going over startup from an airfield, kind of taking a more in-depth look than we've done in the past. We'll be doing a ground power start to afford us as much time to explain shit as we go. And we'll be kind of going over every button and knob as we use it, with a supplementary video afterwards, going over the buttons and knobs we did not use. It's been a bit of a while since we've done this due to the holiday hibernation. I do apologize about that, but hey, we're back in the saddle. Alright, cool. So with any startup of any aircraft, we're going to want to make sure that everything is safe. You can't do a walk around simulation. What you can do is look up at your fuses. So your fuses are here on your overhead console, and it's these guys. They'll essentially work the exact same way that they work in your hovel. If they're pushed in, the circuit is completed, and that function, whatever it is, will function. And if you pull it out, that circuit is broken, and it will no longer function. So for this example, I've got the igniter, I believe. The CB ignition system, yeah. So if I push it in, it's on. If I take it out, it's off. It will no longer function. We'll go ahead and leave that in. Igniter, pretty important. Neat. So that's all in. We're all good to go. Next up is taking a look at our power systems. We may only have time in the short 10-15 minute period to go over the power system and getting that set up, but that's okay. Many more to go in the future. Cool beans. So we've got in this little section here our AC power panel and also our DC power panel. The AC power panel, we'll start with that first. You've got your AC voltmeter selector switch. So that selects what you see down here on your AC voltmeter. The AC voltmeter works a bit different than the DC voltmeter since there is only one input. It works through kind of showing you the sum of the phases, the three phases of the alternating current. So you've got the AB, the AC, and the BC phases. If the power on your dash is showing less for your AB and your BC phases, that's because your B phase has got a fault in it. So your AC phase will be a lot higher because A and C are working properly. That's essentially not going to be used for the simulation unless, of course, you're setting random failures for yourself. And even then, it's kind of just good to know which phases aren't working. Next to that, we've got our inverter. This guy inverts any direct current, DC power, to alternating current, AC power. And yeah, it affects it affects the functionality of most of your navigational aids. So your ASI, your HSI, I believe even, or I guess your compass. It affects your engine oil, your fuel pressures, your fuel quantity indicators, and I believe it affects your marker beacon as well. So essentially, you're going to want to fly with your AC power on. However, when we start off, especially if we're doing a battery start, that will be taking precious DC power and converting it to AC, which is then useless for the startup procedure. So we're going to want to go ahead and leave that off. The inverter, you've got a main inverter. You can set it to use the main inverter, but you also have a spare one in case the main inverter fail. We're going to go ahead and hope that you only ever need to use main, but if that does fail, you know to switch this up. Next up, we've got our DC power, so our direct current power. And this guy's got a bunch of different toggles in it. Pretty important. It's used for pretty much everything in the helicopter except for what I mentioned in AC power. So startup and allows for the functionality of most of the actual functions. So first up, we've got our main generator. So if there is battery power or any other power coming to the helicopter, the main generator is what allows that power to be distributed throughout the helicopter. And should the engine actually be running, should our combustion engine be functioning, it'll convert some of that kinetic energy into electricity. You have the off setting, which is what it is. It's off. It doesn't work. Nothing's happening. You can reset it in case of a fault, or if you're being a kind citizen and you've just shut down the engine, or you can turn it on, which of course will set any power to the distributor. Hooray! You also have this optional cover, which ensures that this doesn't actually get toggled around. Next up, you've got your battery. If it's off, your battery is not supplying power to the helicopter, and you're going to be sitting here for a long time if you're trying to set things up. If you turn it down to battery on, battery power will be supplying throughout the helicopter, which is going to be pretty much required for any startup, as we'll get into in a bit. The starter generator is actually your backup generator. It's what is the generator what's used for starting up the helicopter, so it applies that initial spark to get your combustion engine starting, and yeah, it takes a huge load during startup. But once that's done, you can set it down to standby, which essentially has it function the same way that the main generator does when the engines are running. You also got your non-essential bus, which is your heating blankets. Very fancy name for something very simple. You've got a normal on, which is the 4 position. Normal on essentially means if the main generator is functioning, your heating blankets will also function. So that's normal use. However, say you crash, your main generator doesn't work, but your starter generator does. You probably want to set it to manual on, just so you don't freeze to death in the wilderness while waiting for rescue. So you toggle that up to manual on. Cool. You've also got your voltmeter selector for DC power. That's going to show on your dash this top DC voltmeter. You can show the output of your batteries, or the stored energy in your batteries, the output of your main generator, so the amount going out to the distributors, or that's being distributed around, and also I believe the volts when it's generating. Standby generator is basically that secondary generator when it's set to standby. Essential bus is everything in your helicopter. It's everything but the heating blankets. So for most cases, you're going to want to kind of know if the power is getting to where it's supposed to go. So essential bus is where you want to keep it. Non-essential bus, heating blankets. Very important business. Heating blankets are. Young one. All right, cool. So we're going to set that to essential bus. That's what we want. And now the last thing that we'll go over, because it's essential for getting power running through your system, is this radio selector switch. This depends, or this shows here, this little panel here, shows who you're talking to. Private. It means you're just talking to your co-pilot and you guys can gossip all you like. Setting it to intercom means it's you, your pilot, and anyone in the back, which also is the crew chief. 1, it sets it to your FM radio. 2 is your UHF, your ultra high frequency radio. 3 is your VHF comms radio. And 4 is nothing. It doesn't do anything. Bad simulators. If you ever get confused, just go ahead and mouse it, leave it over for a bit, and it'll show you. Boom. Private hotline, INT interphone, etc., etc. So, like I said, we want to do a ground power start. So we're going to want to talk to the crew chief. So we're going to set to interphone. Oh yeah, I should probably go over these switches. Switches. These are essentially how you turn off or turn on what you can hear. This selector switch here is only what you're transmitting. So if I have it set to 1, I'll still hear what's coming on my UHF or, from the back. These guys, essentially 1, 2, 3, 4, INT and receiver nav, all affect what you hear out of those radios. So 1 FM, 2 UHF, 3 VHF, 4 not functional, interphone, navigation. Hooray, Kaloo Kalay. So interphone, we can talk to our crew chief. Oh, that patch looks terrible. I need to fix that. INT interphone, we can talk to the crew chief. Next thing up, he actually can't hear us. We have no power. He won't be able to read us. So we're going to want to go ahead and turn our battery on. We now have power, as you can hear. We also want to go ahead and turn on our main generator and close that cover, giving us a little bit more time in distributing that power out to the helicopter. We got that alarm. So looking down at the master caution panel light, we can see they're lit up, which means that, again, we have power. So looking below that, we'll have our low RPM warning. This is what, thank God, is what sets that god-awful alarm. So if you turn it off, that alarm turns off, and everyone smiles in relief. If our RPMs raise back to acceptable levels, so if they're in the green here, that spring-loaded system will turn back on, again, warning us in case it falls below again. We also have our fuel. We're going to want to go ahead and turn our fuel on. We might as well. So fuel pump is now functioning. The other things on this panel that are worth noting are the internal auxiliary fuel. This doesn't work, but these are the fuel pumps for any internal auxiliary fuels. Things you might have. Blit. You also have your de-icing. So if ice is detected on the engine, this will use bleed air from the engine back onto the engine, de-icing the system, and also very much increasing your exhaust temperature. So if you ever turn this de-icer on, make sure that your exhaust temperature does not rise beyond this red mark here. We're going to go ahead and leave that off, as our engine icing button, bloop, or engine icing warning, is not on. Your governor is essentially what oxidizes your system. If it's an automatic system, it tries to keep your rotors at a constant rate regardless of the amount of engine power required. If it's set on auto, If you roll your throttle all the way up, we'll just go ahead and do that, then the governor would now kick in and make sure our rotor RPM is always constant. We don't actually want this on though, so we'll turn it off. If you set it down to emergency, we get a little light saying, hey, governor set an emergency, and that means that even if we turn it all the way up, we have full control of the throttle. The governor will not kick on. It's only really useful for when you're like kind of overloaded. We might as well look up at the master caution panel here. We've got a couple options. We can set bright or dim. It doesn't work. Thanks lighting upgrade, or quote unquote upgrade. We also have got our master caution reset and test lights. So pulling it down, make sure that everything pops up. If anything is out, that means that your master caution light does not function, and you want to get your helicopter checked for maintenance, or just reset the game. If you put up to reset, that will make this little master caution light go away. It's essentially acknowledging that you've seen the master caution light, and that allows that to pop back up should anything else come up. While we're up here on our dashboard, we might as well look at our fire detector. So if you push that, your fire detector light should turn on. If it doesn't, that means that that circuit is broken, and either check the fuses or just acknowledge that that won't work. Very dangerous. Don't take off if that's the case. Up above the master caution light, we have the last thing that we'll look at before getting power running through the system. We've got hydraulic controls. You can set it on or off. The hydraulic controls are basically what allows this system, your cyclic, and this system here, your collective, along with your pedals, to actually affect the rotors. I believe for the simulation it doesn't matter. Let's just double check that. Yeah, so you can see I'm pushing it to the left. Trailing edge still kicks up. So that's it's not really modeled in the simulation very well. That's okay. We'll turn it on. Hydraulic controls are now on. Let's pretend that didn't happen. Next to that, we've got our force trim. So the trim in a helicopter works differently than the trim in the airplane. Helicopter movement is or helicopter flying is all about moving the stick. But sometimes it can get very tiring to leave your stick up here. So if you want to essentially reduce the amount of wear and tear on your arm, you press the trim button. Let's go ahead and turn that on first. You press the trim button, and the stick will stay there. I'm now not touching the stick anymore. That's its new default. You can also clear the trim using a button on your joystick that you must bind. The chip detector switch. This essentially is another maintenance detector. If there's engine chips, as you can see here, this will detect them using little magnetic plugs. So if there's enough metal chips to complete a circuit, that light will turn on. This detector can choose which of the two systems of the two fuel systems that you want to take a look at. You can set both, which means that the detectors will work for the transmission and the tail rotor. But let's say it's turned on. Which one of the two is the one with the problem? Well, if you turn it down to tail rotor and the light still lights up, then you know it's a tail rotor problem. If you turn it up to transmission, XMSN, and it turns out, then you know it's a tail rotor problem. Fantastic. We're going to go ahead and leave that at both for now. So with that, we kind of understand what most of these console things do. But we're going to go ahead and get power in. So we're going to go ahead and click our trigger, our radio trigger, and you can see interphone main shows up here along with the communications menu. So we want ground crew. Ground crew we want to talk to, and we want to make sure that we take a look at ground electric power and turn that shit on.
Copy.
And we're going to look at our voltometer here.
Ground power is now on.
And you can see that pops up to maximum. So if we hadn't done that, if we're just doing a battery start, I would have essentially a ticking clock making and we have a ticking clock that essentially would dictate how long we have before to turn on the system before we actually don't have enough power. Since we want to do an airfield start, we're going to want to turn on our anti-collision lights, we're going to want to turn on our nav lights, we're going to want to turn on our landing lights. All that takes quite a bit of power. You can do it on battery, but you can't do it while also describing what every button does. So there you have it. We now have power. Congratulations. That's the first step of turning on the Huey. Next video, we're going to go ahead and show turning on the Huey and spool up, along with setting kind of radios and getting yourself prepped to talk to the ATC. And finally after that, we'll have our supplementary video going over all the extra bullshit I didn't take a look at. Hope you've enjoyed this video and my constant rambling. I'll see you on the next one. Bye-bye.